Hello everyone, thank you for watching our video. We are the 16-inch HVF spring assembly manufacturing team, and we're going to tell you a little bit about our project. So first off, Erie's makes these vibratory feeder trays. They move bulk material down them by vibrating. The tray, as you can see in the image, kind of vibrates fairly linearly, and the base is more of like a circular vibration. The springs, which are the black things on the side there, kind of translate that circular vibration into the linear of the tray to, as I said earlier, help move that material. So here's a video of their current process for getting the springs into the housing. So first they take this hydraulic jack here and they compress those springs more than enough to get them into the housing. And once they compress the springs, they slide the housing over the top. And here is actually a pretty important part of the current process. Once they slide the springs over the top, they're really only covering the top third of the springs, and this is kind of Erie's big safety concern that we're trying to eliminate. They have to move the springs like this after uncompressing or after releasing that hydraulic jack and move it to a hydraulic press, as you can see here, and ram them in the rest of the way. This is not ideal because they can't do this in the field at all. They don't have access to a hydraulic press everywhere that these trays are, so when the springs fail, it's a pain to replace them, and they have to ship them a whole assembly most of the time. So from that, our problem statement is just to redesign the 16-inch spring housing and assembly process to allow for the spring to be compressed within the housing.
So here are two leading concepts that we had after we got through a couple stages of concept refinement. On the left, we have the bolted design. This was characterized by removing one of the face plates that you can see, and it would have been bolted back onto the housing itself. This bolting action would have done the compression of the spring. This design also allowed for those 4 mounting holes you can see in a rhombus pattern on the left design, well, on both designs, but that would have allowed for those mounting bolts to be fastened prior to compression, which was an issue that Erie's was having with their current process now. And then on the right side, you can see the power screw design. This shows a large power screw with a large nut welded to the assembly, or welded to the faceplate of the assembly. This also would have used a spacer plate, and as you'll see in the next couple slides, this was also our final design, but we'll go into a bit more of how that one worked on the subsequent stage. So here we'll go into a bit more about how this, how the final design actually functioned. So first, you put the sandwich mount in. You put the mounting bolts in on both sides. You only hand tighten the ones on the side closest to us. This then allows you to insert the power screw and over compress that spring assembly. You then put the spacer plate in, remove the bolt, and then you fully tighten in those 4 locating bolts. In the end, this spacer plate makes sure that there is the perfect amount of compression, regardless of the amount of overcompression you put on the power screw. This also removes the issue of Erie's having to locate the bolts manually, which was an issue that you could see when they were using the large hydraulic press. Ultimately, it was deemed that this one was significantly simpler than the bolted design as seen prior, just due to the lower amount of moving parts, and it had significantly less failure modes. It was much more conducive to field use, as it only used one tool, or well, it used a couple tools, but primarily it used a large impact wrench, which they would have anywhere that this was being used, because it's primarily being used in mining applications where those tools would be prevalent. Once again, thank you for taking some time out of your day just to check out our little senior design project, and have a great day.